All right, everyone, here is your last Wednesday video before winter break. I know you're all breathing a huge sigh of relief. A couple things we're going to talk about is looking at finding harder inverses, specifically with rational functions, and then proving our compositions using f of f to the negative 1 and vice versa. And then we're going to review some things on exponential. And then I'm going to direct you to where you can review exponent properties, which you've had in Algebra 1 and in Algebra 2 trig, so should be fairly confident with right now. All right, so what if you need to find the inverse of this? Well, one way to find the inverse of this would first be to put it in vertex form, because it's going to be really hard. Even if I switch x and y, it's going to be really hard for me to solve for y when it's in more than one place. And vertex form offers that ability for us to have it in one place. And so remember, where vertex form is a times x minus h squared plus k. And earlier in the year, we used a modified form of completing the square to do this. So in this case, I'm just going to kind of section off my parts. So the negative 5 is still there. But what I want to do is find what would make this a perfect square trinomial. So I take that middle term, I divide it by 2, and I square it, which becomes 1. So I add that here, but if I add 1 there, I need to subtract 1 here, because I can't just add 1 to the equation without changing it. So if I add 1 and subtract 1, I've left it at being 0. Now I can write this first part as x minus 1 squared if I write it in factored form, minus 6. What's nice about this is now I can see that my original domain for parabolas is always all real numbers. And I can see that my domain for this, since it's facing up, had to be, oops, that should be a bracket, negative 6 to infinity. Now, if we're going to find the inverse of this, we want to restrict our domain. And so if this graph, if I sketch it, has a vertex here at 1, negative 6, I could just take the right branch of it here. So we're going to restrict our domain to be 1 to infinity. That's our new restriction. And now we want to go through the steps to find the inverse. So we switch x and y. I'm going to add 6 to the other side. So I get x plus 6 equals y minus 1, and all of that is squared. Then I'm going to square root both sides. And remember, we're only going to take the positive branch of it, so I'm not going to have plus and minus. I know this is a little confusing. So I have the square root of x plus 6 over here equals y minus 1. And now if I add 1 to both sides, and I'm going to use correct notation now, my f to the negative 1 is going to be the square root of x plus 6 plus 1, which is a square root function that's moved left 6 up 1. And so my new domain is going to be whatever my old range was, so negative 6 to infinity, and my new range is going to be 1 to infinity. Hopefully you guys can see all that. So let me put that all in there. You may want to pause and get this all in your notes. All right, what we haven't done yet is we haven't looked at finding inverses with rational functions. And so we're going to look at that today with function k here. And first thing we want to do is find our original domain and range. And so our domain is only going to be restricted by what makes this x 0. So if I set 3x minus 2 equal to 0, I can see x equals positive 2/3. So my initial domain says x cannot equal 2/3, but everything else is fine. And then my initial range is going to come from the horizontal asymptote, which we haven't talked about much. But notice that n equals m, and so my horizontal asymptote is y equals 4/3. We want to see if we cross that. So just see if we have any restrictions for our range. So we have 4x all over 3x minus 2 equals 4/3. I'm going to cross multiply. So I get 12x equals 4 times 3x minus 2. And distributing that, I get 12x equals 12x minus 2. These are going to cancel out, so I don't cross my horizontal asymptote. So that's my restriction in my range. X cannot equal 4/3. All right, if you have more questions on that, make sure you ask that in class and we can talk about it. So having my original domain and range right here, I should be able to get the opposite when I find my inverse. So step 1 replaces the x's and the y's. So I'm going to get x equals 4y all over 3y minus 2. Now I want to multiply both sides by 3y minus 2 to get rid of the part in my denominator. So I'm going to get 3y minus 2 times x equals 4y, and I'll want to distribute that. So I get 3xy minus 2x equals 4y. Now here is like, okay, how are we going to get this y by itself? I have no freaking clue. Well, what we want to do is we want to get everything on one side that has a y in it and everything that doesn't away from it. And this is an x. I know, sorry, I made it look like a y. So I'm going to subtract 4y from both sides, and I'm going to add 2x to the other side. And that's going to give me 3xy minus 4y equals 2x. And now I can get y by itself because I can factor it out. It is the greatest common factor on the left of the equal sign. So y times 3x minus 4 equals 2x. Divide both sides by 3x minus 4, and I get 2x all over 3x minus 4. So coming over here, correct notation for that is k to the negative 1 of x equals 2x all over 3x minus 4. So there's lots of scribbles for you, so maybe pause and get that down. The second part is we need to prove that these functions are inverses of each other. Before I do that, I want to make sure that my new domain makes sense. So my new domain is x cannot equal 4/3, and that does make sense if I look at my denominator now. And my new range is y cannot equal 2/3, and that makes sense because that's my horizontal asymptote. And if I didn't cross it before, I wouldn't cross it now. So composition we're going to first put this inverse into our original, which is up here. So everywhere I see x, I'm going to put my new function in. So I'm going to have 4 times 2x all over 3x minus 4 all over 3 times 2x all over 3x minus 4 minus 2. That looks completely easy, right? You guys have got it. I can just let you finish this up. I'm looking at it and I don't even want to do it. But I'm just going to distribute. So I'm going to distribute my 4 and my 3. And that gives me 8x all over 3x minus 4 all over 6x all over 3x minus 4 minus 2. I need that 2 to have the common denominator of 3x minus 4. So I'm going to multiply top and bottom by 3x minus 4. And I still have 8x times 3x minus 4 on top. But now on the bottom, if I distribute my 2 and I put everything all over my new common denominator of 3x minus 4, I get 6x minus 6x plus 8x. And hopefully you can see where this is going. These add to be 0. And I end up getting 8x all over 3x minus 4 all over 8x all over 3x minus 4. Oh, sorry, this is just plus 8. Sorry, just plus 8. And when I write this, if I take the inverse of this, or the reciprocal, and multiply, that's how I divide fractions. These cancel out, and I'm left with 8x all over 8, which equals just x. And you would do that the other way as well. All right. It's going to be a longer graph than I want it to be, but I just want to remind you of a few things about exponential functions. So our parent function is y equals b to the x. And remember, this is where our exponential functions fit in. So we have done linear functions. We have looked at a lot of power functions, which include polynomials and rational functions. These are our rational functions down here because 1 over x or 1 over x squared. And now we're going to look at exponential functions. And so exponential functions, remember our a value was always our start value. And b was our growth or decay factor. And so if b was greater than 1, it was growth. So notice we have all the information about that there. If b was between 0 and 1, it was decay. So notice growth is repeated multiplication. Decay could be considered repeated division. But either way, my domain and my range are the same. For the parent function, we had a horizontal asymptote at y equals 0. It is a one-to-one function, so you guys know what that means, that now it passes the vertical line test and the horizontal line test. And then something else to get in your notes is the transformation form. So this is growth or decay, otherwise known as stretch or compress. This shows if it moves right or left, and this is up or down. So maybe you guys want to pause and get all this on your notes. I have just one slide left to show you. Your assignment attached to this will be on Schoology. So just a quick review of the graphs. This is also in your book. A lot of it we repeated. We said it's a one-to-one function. We have a domain that's all reals. We already said whether it's increasing or decreasing, so growth or decay. And notice though, we added one thing, the y-intercept is 0, 1. And so if you shift that up or down or right or left, your 0, 1 is going to move, and also your first point, which shows your stretch or compression, otherwise known as growth or decay. So again, maybe take a pause on this part of the video and make sure that you have all this information. All right. So don't forget to look on Schoology for homework number 40. It's just a few problems. And then, oh, one other thing. I will show it. If you need to review exponent rules, which we are considering just to be a review at this point, you should go to appendix pages A through 10, A10 through A14, and then there's also problems on page A20, problems 7 through 66. We will not be covering these in class. If you need to review the addition and subtraction rules and all those of exponents, you know, power to a power and anything to the 0 power, then maybe you'll want to check that out in the appendix. All right. See you on Thursday, Friday.